What's happening, dogs? Mr. Allen here with some graphing of trig functions, and we got ourselves some transformations in these two examples here, so let's get after it, man. We got a -3 cosine of theta minus 1. So there's no phase shift or anything like that because there's nothing in the cosine function, but we do have a reflection, a vertical reflection. We got that 3 there. That's my amplitude for this one, and we're going to be moving down 1 here. So actually my midline, and I'll write that, my midline, that's going to be y equals -1. So everything's going to shift down 1. I'm going to go ahead and start scaling this thing here. 1, 2, 3, 4, -1, -2, -3, -4. So a lot of times we'll leave the scaling up to the student for these things here so you can appropriately scale your x-axis and y-axis based on, your period or whatever it may be, okay? So we got a midline of -1. So I'm just going to dash that in right now. That's going to help me when I'm graphing this cosine function. My period, we already skipped over that. I don't know why, but that's going to be 2 pi, right? Our period of any cosine or sine function starts as 2 pi. And then if there's something going on like we have here in the second example, we'll have to adjust that period. All right, phase shift. We said no phase shift, so none. Domain and range, let's tackle that after we graph this thing, all right? So with graphing of trig functions, it can be helpful just to kind of get into a rhythm and like a pattern of how these things work. And if you can start off at the right point, you should be good, okay? So we said no period change, which means that my scaling will be the same, pi over 2, pi, 3 pi over 2, and 2 pi that we see from, our parent function of these graphs. All right, so the -3. Normally, my cosine graph starts above the midline, right? It starts 1 above the midline, but it's negative, so it's starting below the midline, and it's a -3, so our amplitude's 3, which means I'm going to start 3 away from that midline. I'm just covering up my -4 there, but that is my point, okay? So I am 3 away from the midline, below the midline due to the negative there, and we've already taken care of that midline with the -1, so we're all good. Then, when I'm off of the midline, I always got to go back to the midline. So I've got to be on the midline for my next point. And now that I'm on the midline, I got to go above the midline by 3. 1, 2, 3. So we're going to be chilling right here. And now that I'm above the midline, I got to go back to it. Okay? I'm never going to stay above or below the midline for more than 1 point. I'm always going back to it. All right? Then for 2 pi, I'm going to be 3 below that midline right there. Excellent. All right. My next point, I'll even do some extra points here, but I'm going to do the green here will be my 1 period of this. So my orange, I'd be back on the midline here. Over here, I'd be back on the midline. Then I would be above the midline. So you can get into this like rhythm here, right, where we're just up and down, up and down, up and down. All right. And if you lay everything out ahead of time with that midline and stuff and you're scaling, you should be good to go. So here we go. I've got this guy coming back up. Whee! Then back down. Always good to see where you're going. And then we're coming back up here. So this would be my 1 period. So if your teacher asks you to graph 1 period, that's it. All right. Now, if we are asked to do a little bit more, cool. Or if you're given the option to, this is what would happen with my graph. It would continue on, right? This one would come up, and then it would be coming back down thereafter. So that's a continuation of this graph because these are called periodic functions. They periodically repeat themselves, in this case, every 2 pi. So this will go on forever and ever and ever if you let it. If I had enough light board to continue, I could just keep going. I could be walking down the block, right, as I'm doing this thing here, and just the cosine graph's just going to keep on going. All right, there we go. Domain and range. Let's finish this one up. So my domain, those are all my x values. As I just said, it just keeps on going. So, or excuse me, all my theta values. We'll say theta equals all real numbers. All right, so goes on forever, never ends. Awesomeness. My range, how high and how low? Well, I'm going to be between, let's see here, -4 and +2. So there's a couple ways to write that. I'll do interval notation with this one, -4 to +2. I'm going to be bouncing around that. I'm including those points because those are points on my graph, but I'll be including that in there. I use the bracket notation. You could use inequalities there if you'd like. I just prefer interval notation when I'm talking about just between 2 numbers. I feel like the inequalities get kind of messy and a little too much to write. But it's all about what your teacher wants. You know what? I will go ahead and write that version for you as well. It would be -4 less than or equal to y less than or equal to 2. So this is the equivalent form right there from interval notation to our inequalities, or sometimes referred to as set builder notation. Some people get real formal with it, man. They're They do some brackets and they're like, why such that this stuff and more. Oh my gosh, dude, calm down, mathematicians. Let us just chill, okay? Keep it simple, right? That's my opinion. Anywho, gotta follow what your teacher asks. Okay, next one here. We're gonna graph sine. So we got y equals 2 sine. Then we have 1/4 in parentheses theta plus 2 pi. So it's super important here that this one's already in this factored form here. I can identify my transformations when it's in this form. If it was not, if these parentheses were not here, I'd have to factor out that 1/4. I'll do that in another example so you can see that. But this one's already good to go. It's already in that factored form. We're set, we're ready to rock and roll, and I analyze this thing. All right, so my period, okay? It is 2 pi that it starts out for sine divided by this b value here, okay? So for period, it's 2 pi divided by b. That's how we get our period, okay? So for this one, 2 pi divided by 1/4, I'm going to possibly run a, we should be okay. Maybe. You know what? I'll do it down here. 2 pi divided by 1/4. Well, that's really going to be multiplying by the reciprocal. That's official mathematics notation right there, right? And that's going to give me 8 pi. So my period is going to be 8 pi. So here, equals 8 pi. Okay, cool. So from there, I also like to decide what my scaling is going to be, okay? So I always will take this 8 pi, my period, and I'll divide it by 4, as I want 4 chunks, if you will, along my graph. So I'm going to be scaling by 2 pi's. So that means that this is going to be 2 pi, this will be 4 pi, 6 pi, 8 pi, so on and so forth. But we'll just do those. Maybe, looks like we got a phase shift here. I'll go back 2 pi as well. What the heck. I'll just go ham with the pi's. 10 pi. Whee! Okay, cool. All right. Lovely. Period taken care of. Amplitude. I've got a 2 in front there, so my amplitude is 2. I'll go ahead and just go by ones this time. 1, 2, 3, 4, so I don't get too high up. -1, -2, -3, -4. Phase shift. We do have a phase shift. We're going left 2 pi. So let's get to graphing this thing. My sine function always starts on the midline, right? I did not move up or down, so my midline is the x-axis here, which has been appropriately scaled. So I don't have to worry about this guy anymore, the 1/4, right? Because that's been taken care of in my scaling. But I do need to worry about my phase shift. I got to go to the left 2 pi. So now I'm going to start on the midline, but at 2 pi. Next move for a sine function is to go above the midline, right? And it is positive, so I am going to go above. If this was a negative out in front, I'd start by going down. But because my amplitude is 2, I'm going to be going up 2. So that lands me here. And then I'll be back to the midline, then to below the midline. And as you can see, we just do this little pattern here. So that's a full period of this sine function. But we can continue on, and I'll do that in orange again. Right over here, I'm going to go above, then back to it. Over here, let's see here. I'm above, then I'm on it, so now I'm below it. All right? So we should never like bounce off the midline or anything like that. It should always go above it, back to it, below it, back to it, above it, back to it, below it, back to it. All right, that's enough. So now I can connect some dots here. Always helps to see where you're going so you can get a nice, little curvature to it. Beautiful, fantastic. That is my one period of the sine function, but we could continue on, as I will do with this dashed orange marker, showing that it does go on forever and ever and ever. But that is my single period of this sine function. It is an amplitude of 2, has a period of 8 pi. You see from -2 pi to 6 pi, that's 8 pi right there, right? And it had a phase shift. We shifted to the left 2 pi, because on the inside it is opposite. You need to go the opposite direction there. It's about what would make, so that -2 pi would make the inside here 0, which is what we want for our normal starting point. So that's where the opposite sign comes in, which is kind of weird, but it does work out mathematically. All right, there we go. Got some more coming your guys' way. If you need some more practice with trig functions, all right, because they are super fun to graph. And then we got reciprocals, man. There's still some tangent and cotangent. Oh, my goodness. It's going to be awesome. It's going to be fantastic. See you later.